today's session. Africa Hyperscalers is a market intelligence and ecosystem platform focused on accelerating Africa's digital infrastructure economy across data centers, cloud, connectivity, power, and policy, moving the necessary conversations from ambition to execution. And today's discussion is one of those very important discussions, and it's quite timely too. So globally, AI investment is accelerating, and this especially was front and center at Davos last week for those who followed it. This interest is also rising across Africa, across banking, telecoms, manufacturing, energy, and of course the public sector. But as recent conversations have made it clear, AI is no longer a software discussion. At Davos, Masiwa joined a session alongside Brad Smith, Rishi Sunak, and some others, and made the point very clear that AI will not be limited by ambition or models, but by infrastructure. And by infrastructure, we mean the power, the ability to scale, resilience. And that is the lens that we're looking at today. This is a practical session that we're hosting with Vertiv about the fiscal and operational foundations required to run AI workloads reliably today across African operating environments. And that is why we're very pleased and excited to be partnered with the Vertiv team. So before we get into the session, very quick housekeeping. This session is in webinar mode. Speakers are visible, and then we'll take questions at the end. There will be a curated question and answer session at the end where we can take all the questions. So please just note whatever questions you have for any of our speakers here, please note them down, and then we'll have ample time to field them. I'm pleased to be joined by our speakers from Vertiv, Gary, Chomse, Okechi Osuagwu, Olajide Aminu, Luther, Ogbaji, and Wilson Ekbaidon. And then as we go to the very next session, Gary is going to give us a very quick intro to Vertiv. Gary Chomse is Regional Director, Central and Southern Africa at Vertiv. He has over 25 years experience in critical infrastructure and enterprise technology, and he has held senior leadership roles across Africa and the Middle East. And he currently leads Vertiv's Central and Southern Africa business, driving resilient AI-ready infrastructure deployments across Central and Southern Africa. So please, let's welcome Gary, and I'll hand over to Gary now, who will give us an intro to Vertiv. So Gary, the floor is yours.
Thank you very much, and yeah, thank you very much for including me on the panel. It's great to be here, and I hope that all the attendees get some good knowledge out of the session that we've planned. I don't think there's much to be said about me, as you've already introduced me. I've worked for Vertiv, and previously known as Emerson, for around the last 23, 24 years, in various roles across Africa and the Middle East. My role currently is Regional Director for Southern and Central Africa, that being mainly the SADC countries of Africa, as well as in the Central region, Nigeria, very important region for us, Ghana and Cameroon. So I have a team sitting in Johannesburg, South Africa, and a team in Nigeria. So just a very quick high-level overview of Vertiv. We're very, very happy to announce that we were listed on the Fortune 500 of the New York Stock Exchange the latter part of last year. A very proud moment for us, having only been listed on the stock exchange since it was around about 2017, I think, 2016, 2017. So a huge milestone for us. Currently, we're at about an $8 billion turnover company, 35,000 employees all over the world, as well as manufacturing, sales, and service centers in regions right across the world. Not surprisingly, our biggest market is in the Americas. And EMEA, but we form, being Africa, we form part of the EMEA region, and over the last few years, we've seen us growing very, very close to catching up to the Asia Pacific region. So that is what our aim is to get bigger than the Asia Pacific region. Financial sectors, medical, healthcare, mining, a very big focus of ours, education, government, what else? Manufacturing, retail, and really is becoming a big focus of ours. We think it's a sector we haven't spent a lot of focus on in the past, but it's a big focus of ours currently. The products or the solution lines that we work in, our biggest part is the critical infrastructure, and that's really where our data center expertise and experience comes in. It's the critical infrastructure for data centers, hyperscalers, co-location sites, as well as telecommunication sites as well. Integrated rack solutions is a smaller part of our business, but that is also growing rapidly. And then obviously the full services and maintenance and after sales service that we provide across the board. As I was saying, critical infrastructure is what we do, and it's across a number of different business lines of ours, or what we call business units. And that is from power management, being AC power, DC power, bus bars, switchgear, etc., to thermal management, where we are one of the leaders in the world for sure in the data center industry. High precision cooling, immersion cooling, condensers, etc. And then we've got the IT systems part of our business, which is making a big inroad at the moment. PDUs, racks, enclosures, cooling for those racks, cold aisle containment, hot aisle containment, etc. On top of all of that is of being able to offer the whole package. Okay, so all of those systems I've mentioned above into what we can call a data center in a box, or modular data centers, where we manufacture the whole data center in modules in one of our factories in Europe or in China or in India or in the UAE. We then dismantle them, send them to site, and put them together on site. Ready-made data center once it's installed on ground in country. We're finding a lot of success with that in Africa due to the infrastructure issues we have in Africa. That is a ready-made data center put on the ground, ready to run. And then, as mentioned before, our services around all of those product solutions. We've got either our own service personnel in country, or we have an approved services network in all the countries throughout Africa. And that's how we run our services and look after our customers from a services perspective. All right. Please excuse me if I'm hesitating a bit, but I see, Jamoke, it looks like you've changed my slides, but I will read through them anyway. These are not the slides I saw yesterday, but no problem. Carry on. Let's go one back. So just to go through some of our customers in Africa. Historically, up until 2010, 2011, telecommunications was a huge drive for us in Africa, as many of these big mobile network operators grew the cell phone industry in Africa. So MTN by far was one of our biggest customers throughout Africa, and a great customer of ours. Along with that was Vodacom, very much. We worked very closely with Ericsson. We worked very closely with Airtel. Who else are the other ones in Africa? Orange, we worked with. Then on the data center side, I mean, we're still a very big supplier to Equinix, DLR, NTT, Vantage, and then some of the independent data center companies, Rack Center, PAX, PAX, what's the other one? Rack Center, PAX. Oh, sorry, I've just gone blank on the other ones. Onyx, sorry, Onyx is the other one. Some of our IT alliances and the IT partners we work with is Dell, very, very good partner of ours, and we're making some very good inroads working with them in Africa as well. Oil and gas, Chevron, Shell, and as I mentioned earlier, mining, very much a big focus of ours, and having some great success in the Southern African region, in South Africa and Zambia and Tanzania specifically. All right, I think I've pretty much covered this. As I said, data centers, telecommunication networks, commercial, industrial is where we play, and are very successful in the African environment. All right, thank you very much, and thank you for this opportunity to introduce Vertiv. Let's hope you get a lot from this session.
Absolutely, Gary. Thank you so much for a very elucidating intro into Vertiv. So I'm now happy to bring Okechi Osuagwu, who will walk us through innovation for modern data infrastructure, and we can already see his screen. Okechi is the regional account manager, Central Africa Vertiv. He works closely with enterprises that are transitioning from legacy IT to AI-ready infrastructure, and he supports CIOs and infrastructure leaders in designing scalable, resilient power and cooling systems suited to Africa's operating environment. So please, can we welcome Okechi? Okechi, over to you.
Yeah, thank you very much, Temi. You did a good justice on introduction. I could have done it even much better. So good morning, everyone. My name is Osuagwu Okechi. So I work for Vertiv, and pretty much Temi has done good background info. So I just want us to look at the trend that is happening because of the AI revolution. The idea of AI has been there since 1950s, 60s, but there wasn't much development, acceleration, because the needs, the tools to get it working wasn't coming forth. Not until let's say 2010, 2015, that a lot of improvements were being done on GPUs. GPU is a graphical processing unit, NPU, neural processing unit. These are AI accelerators. So this weren't possible earlier in the 50s and the 80s. So that's why the push for the AI wasn't much available then. Now that we have this, there's a lot of trend that is now going on. You can see, I've been in industry over 2 decades doing IT infrastructure. If you look at when you want to design a data center, you look at what we call rack density. For over a decade, we keep on doing between 3 kilowatts, 5 kilowatts per rack, year in, year out. This is normal standards. But if you look at since 2022, this has been jumping astronomically. So we left the band of 5 to 15 kilowatts. We just jump into 20 to 50. Now we are doing like 80 to 140, and there's a projection before the end of 2030, we'll be looking at 300 to 500 kilowatts per rack. And you know what this one means in terms of the infrastructure that will be required to run this kind of power. Next, please. So now what I have on the screen is the building block of a typical data center. So you have your switch gears, your UPS, your power, your cooling. So that means if you don't rethink the way we do these things, the what we have cannot really work. I've been in one of the seminars where I asked who has AI-ready data center, and I didn't get any response. Obviously, most of the data center built last 5 years, last 10 years cannot run the AI revolution. What it means that we need to rethink the way we design this our IT infrastructure, the way we design our switchgear, the way we design our generators, our ATS, to align with this constant change, this constant jump in the power requirement occasioned by the AI revolution. So what I'm going to take you through is to see what are we doing, what is Vertiv doing to make sure that we have an already made solution. So as the AI revolution is jumping, our equipment and IT infrastructure are adapting to what is obtainable. Next slide. So now, in terms of power, so we have to look at our UPS, our power generator. The way we design it, does it adapt to the GPUs, which are the basic components of a server that runs in an IT infrastructure? Then look at the power. There was a time I read people in California, which is the Silicon Valley, they were complaining that American power distribution system is insufficient. It cannot cope up with the rising trend in AI requirements. So Trump told them, yeah, you guys, you are rich. Why are you bothering yourself about government IT infrastructure? Bring your own power. So he now told them that normally they can go for nuclear power. Nuclear, there is not what we call them small nuclear reactors. So what it means that for the trend and the rush with AI, the regular things, the system we have will not work. So we need to rejig how we do our things. So he said that he can approve nuclear plant for them in a matter of 3 weeks and go. So that's the only way to meet up with the power demand for the AI. So in thermal management, we are more comfortable with the normal air cooling system that we normally have. But we can see with power being concentrated in a smaller chip, this air cooling is not going to be the issue. So there's a new shift, new paradigm shift to look into liquid cooling, because liquid conducts more better than air to remove the heat being generated by these GPUs. So the way we design our cooling is now changing. Also, our racks and enclosure. So we need to look at smart racks, the racks that can adapt with dynamic IT loads and co. So this will look into it. Then design process. So if you look at normally, what would you have a traditional data center that might take us 6 months to 1 year to, in fact, if you look at from conception, it might take you 2 years to conceive and bring a data center to life. So it then means by the time you finish designing a data center, it's already obsolete. So it then means that going through that part will not meet up with the normal trend we are seeing now on the data center development. So we need to rethink what we do. So next slide. So Vertiv have come up with what Vertiv call 360 AI. This 360 AI is a streamlined process where all the systems are pre-engineered, then the design are validated, and will design and ship out. So those idea of conceiving, sending equipment individually, those are gone. What we now have is a complete system that's based on requirements, based on design consideration. This will just be put up, manufactured, and shipped to sales. So for even the IT architecture, the facility structure. So I would just, before I continue, I would just for us to take a little time to look at how we're bringing this into life. We will need to watch a little video. So after that, I will continue. So do you want to? No sound?
The sound seems to be off, Jumoke.
Can you turn back? Okay. Even though the sound is not there, but at least let's watch the screen. This is a design process for data center, a smart data center that's been
Okay, Okechi, can you hear me?
Very, very well, I can hear you.
Okay. I didn't hear you for a bit.
Okay, I wasn't seeing the slide. Okay, hold on.
Okay.
I'm waiting for the slide to come up.
Yeah, I can see Aminu sharing something.
Okay.
We can see your screen, Olajide. At least we can see the background.
Yeah.
I think Olajide is already reflecting on his vacation.
Uh,
Okay. We can see your screen now. So Okechi can walk through it. Still no sound, but you can walk through it.
okay, so this is actually showing us how the process of designing a modern data center from a conception when you have an idea of what you need to do, how you engage with a Vertiv team or Vertiv partner, so how your design is validated. So in the factory, everything is assembled, then tested, and certification and everything is done. Then when you come to site, all that needs to be done on the site is to make a plant, and all these are dropped module by module to the site. So you can have the different arrangements. You can grow vertically, you can grow horizontally. So look at it, this is inside the data center. So it doesn't look as if it's a container. So each of the containers are done individually and tested on site, then brought to sites just to deploy. So when everything is done, you ship, see how the individual containers are being loaded on a truck to be shipped out. So that's from the ship down. It's been getting to the location. Thus the plant is ready. They're being dropped individually. Then commissioning is done. So the only thing that is done on site is to commission, to test all the different components and then power everything together. So you save time and a lot. So thank you. So let's proceed. So for the modern data innovation in modern data center, so we look at what you used to have in the past. So my left is the regular thing. Everything is a silo. The UPS is from a different vendor. The racks from a different vendor. The distribution points are different vendors. And everything is manufactured individually and brought to site. Then when you get to site, a lot of serious integration and compatibility testing is going to happen. But now we're moving away from that. We are moving into a smart solution. It is a solution that is all encompassing. So everything from the design, from all the are re-engineered from the design stage and brought to site in terms of as a module. Next slide, please. So now for Vertiv, we have different range of the smart solution we are talking about. We have a smart cabinet. Smart cabinet is a data center in a cabinet. It comes in different sizes, the 42U, the 36U, the 12U, and but this is a mini data center because, let's say now, as we grow, not every organization require a big data center. Some IT might require something small. So this smart cabinet will come handy when it's just the customer need. Then after customer smart cabinet, we have what we call the smart row. So this is a data center in a row of rack. So you can have different rack just in a row. Then we have what we call the smart eye. So this is a data center that is in a pod format. You have the rows. So everything is encased in a system. Then we have what we call the smart mode. This is a data center designed inside a container, a containerized system. So what it means that when you have this kind of data center, you don't need to a house. So they can stay outside. So the components, all the necessary components that comes in the data center are there. So this is a typical smart row. So you can see your PDU, the containment system, the cooling, everything is done. That's arranged. So next slide. So just let me a little bit to design. So the smart cabinet will have every necessary component that comes in the data center: the power, the UPS, the cooling, the environmental monitoring, and the CCTV, all encompassing inside the system. So next slide. So one of the key advantage of this our smart cabinet is that we have what we call tricolor monitoring system. So if you look at, we have the one that is blue, red, and white. So from remotely, without even coming close, if you see the data center, the light shows blue, it means everything is working normally in the data center. So when you see it red, it means that's a problem. One or two things in the data center is having an issue. Then when it's white, it means the data center cabinet is open. So not necessarily coming into the data from afar, you can just have a glimpse of how your data center is behaving. So this is a typical one we deploy for a customer. You can see how is arranged the smart row. So this has, thank you. No, go back at this one. Yeah, sorry. So in the smart row, we can have a density of 20 to 30 kilowatts, and you can have up to 3 to 10 racks in a row. So this is pre-engineered and design. So the next one is the smart eye. So the smart eye this is a typical one we have in a site. So this was taken from a picture from a site, and this that was done, it was therefore certified. So uptime certified even before it left the factory. So we don't need to now have to come to site to do certification. Next one. So the systems that are in this smart eye, you have all your different components, the UPS, the monitoring solution, and so one good feature of this is the roof lock. So the roof lock, whenever there is maybe let's say power outage, whenever there's power, the next thing that jumps up is that the heat inside the data center will start going high. So the roof will drop automatically to allow fresh air to get into equip the equipment before maybe the power is restored. Also, if there's a fire incident, this roof will also drop down to allow the FM200 that might be outside to sprinkle fire suppression system into the data center. So next. So now the last one we have is the smart mode. So the smart mode is the data center inside a container. So like the one we watched in the video, where we have everything being engineered from factory, done, tested, and now shipped in a containerized system and delivered to site. So all your system, like the cooling, you can see the cooling that is outside the condensers. So these are packaged inside the system. When you get to site, the container open and the condensers are mounted outside. So, and for this one, we can have a density of 30 to 400 kilowatts, and we can have up to 16 to 28 racks, depending on when you want to do a standard 20-foot container or on standard container. But why would I normally like to stick with the standard container is that for easy of shipment. So it is to be designed based on the 40-foot or 20-foot container dimension so that it can sit well on a truck that is moving. So bringing it all together, we have the advantage of our smart solution. It reduces your deployment time. You can save up to 50% of the time you would have wasted doing your regular data center. So, and the solution allows you to scale. So as it comes in the module, anytime maybe you want to upscale, or you just need to just buy another module, put it vertically or put it horizontal to join your existing one, and it can scale. So which is one of the limitations we are having today. The existing data center is very difficult for you to scale because it has been built to the maximum from day one. So, and it's very flexible, and the solution are customized as per customer requirement. So the power and cooling are close coupled, tied together. So the power requirement has been designed, the cooler has been designed as a power requirement. So you won't have issue of having undercooling or improper power, because everything has been tied together to match the requirements. So, and we have local supports that support all this when we bring it to different sites we have deployed. Thank you.
Okay, thank you, Okechi. Happy we have been able to get some time from that. So now I'm very happy to welcome Luther. So Luther will be focusing on thermal management, an area, this is a very big area that AI fundamentally changes the rules. So Luther Ogbaji is application engineer, thermal sales at Central Africa Vertiv. He is a thermal infrastructure specialist with nearly 2 decades of experience in HVAC and data center cooling, and he supports AI-ready thermal deployments across Central Africa, spanning liquid cooling and next generation cooling architecture. So my pleasure to welcome Luther. Luther, over to you.
All right, thanks very much. It's good to be here again and talk about cooling and what the future holds for the data center industry. As I've been rightly introduced, we're just going to go through thermal densities and solutions available from Vertiv perspective. So like Okechi already mentioned in his slides, he spoke a lot about rack densities and heat loads that in the coming years will continue to increase because of data processing ability, in everything we do. Apparently, the world revolves around data at the moment, and that means every single year, we're going to have an increase in data consumption, and then the speed at which we will need it to be consumed. We were so familiar with the air cooling, and today we're going to do a lot of talking about the liquid cooling. It's the in thing. It is what will be able to arrest the high density racks that will be produced in the nearest futures are already existing. Automatically, it's not like we're going to leave air cooling redundant completely. It is still going to participate in data center solutions. Having said that, on this presentation, we'll try to evaluate and see the different types of liquid cooling solutions we have, and the advantages or disadvantages, or the things we need to do to prepare for liquid cooling solutions in our data centers. We're going to hit the slides quickly as we talk, because I'm not reading the slides. Okay, so liquid cooling alternatives. Here we have our liquid to air cooling, rear door heat exchangers, and immersion cooling. These are 3 different types of liquid cooling solutions meant for high density racks. And like you can see, the first one, the liquid to air CDUs. It goes from your CDU, which sits by the side of the rack, into the rack, and does some kind of cooling right into the servers. So same with the rear door heat exchangers, but most importantly is the immersion cooling. This is a very complicated kind of cooling solution for high density racks. Automatically, the rack sits inside the liquid, and a lot of people call this liquid water, but again, it's not water. There are different types of this liquid available from different manufacturers, and Vertiv, of course, has chosen a manufacturer that provides their own liquid, and it's dipped right inside the fluid to be able to extract the heat load that comes from these racks. And what you see on the screen is a pictorial view of what your cold chip, how the chips are being cooled by liquid. Okay, so you have your CDU sitting outside, and then it is piped right into your rack, and then into the server. So automatically, like we used to have air cooling takes away, or the fans blow out the heat from the servers, and then the air takes it out. It is moved from that perspective because of the quantity of heat now generated. So you can see your red line and your blue line. Automatically, your cold plate, your secondary fluid network, your coolant distribution unit sitting outside, your secondary fluid network, it's that fluid that flows right into your cold plates. And then takes the heat, just like sticking a rod inside water or something, a hot rod, and then expelling the heat almost immediately. In our efforts to get rid of this high density heat load, we have a liquid cooling in our data rooms. Okay, this is just telling us to be prepared for liquid cooling, if not now, soon. Don't turn off your ACs yet. Like I said, your air cooling is not going anywhere. Double check your data sheets. Keep in mind the 5 F's when bringing in fluids into the data hall. We're going to discuss this in detail in the next slides, and then dig deeper into the many liquid options, applications, and sites needs that are unique. The next slide. Okay, great. So this they are giving us the statistics of what the projection of liquid cooling in the coming years. We were already in 2025. I mean, we're done with 2025 and we're heading towards 2030. And you can see the projection, 1,400. I mean, this is quite high. And the reason for this is, of course, the kind of AI chips they're going to be using for data production in the nearest futures. So that is technology. And this is a feedback from Ombia on the projection of the use of liquid cooling in the nearest future. Click the next slide. Click the next slide. Okay. Okay, like you can see here, low density up to 10 kilowatts, medium density 10 to 25 kilowatts, high density 25 to 80 kilowatts, and then extreme density, like Okechi mentioned in the slides, from 80 kilowatts up to 200 and even 300 in the coming future is what we'll be expecting from our servers. So at every point in time, the cooling solution for this kilowatts of cooling or the density of heat load changes. So of course, you can see from the slide, between 10 kilowatts to maybe 80 kilowatts, we're still good with perimeter cooling, road-based cooling, and maybe passive rear door cooling. But as the heat begins to increase from 80 kilowatts and above, we have to move to direct-to-chip cooling and immersion cooling, like we saw in the slides before. So again, technologies to extract heat from data rooms could be direct expansion or chilled water. If you are going to do 10 kilowatts to 80 kilowatts, you can either choose direct expansion, which is gas, using gas, and then chilled water, which of course we're all familiar with the chillers, the big chillers that take away, we install in big data centers, So as the heat increases, extreme heat requires direct to chip and immersion cooling, which we already looked at slides talking about them. We already talked about this slide. I think it's a replica of the slide we spoke about before. So digital habits, energy and compute capacity, generative AI. I think Okechi spoke a lot about how this has been addressed. I mean, what is expected to be generated between now and 2030, and the energy it consumes, and how we're going into nuclear energy to be able to match data center energy consumption, and the ability to generate that is another thing altogether. For us in Africa, yes, it's a big challenge, but it's something we should start looking at experts in the industry on how to generate power for data centers specifically to avoid all the excessive expenses on, of course, we know diesel consumptions and all that within our own sector. So for our own client here, talking about power generation is something that it's a whole lot of topic on its own when we want to address data center power consumptions. Hit the next slide. So the likes of Dell, the likes of HP, and all server producing companies are in sync with this new technology and how they're going to provide or produce racks, or rather servers, that are compatible to liquid cooling deployment. So, like the slides show you, these blue lines you see are all, and red lines, they are pipes connecting liquid cooling right inside your server. Just like telling you that the handphone you carry, I mean, when it generates so much heat, instead of dropping it to the air cooled, I mean, a lot of pipes pass through in there to extract the heat and take it out to the red lines you see to your external CDU unit or whichever type of liquid cooling solution you've decided to deploy. So apparently, server companies are beginning to design servers to match with the capacity to run with this AI-ready cooling solutions, which is liquid cooling that we are talking about. Click the next slide. This is the same thing we've talked about. Rack densities are above 40 to 60 kilowatts and all that. So yeah, networks are mission critical components and part of liquid cooling solutions. So like we earlier said, there are things to look out for. A lot of people will tell you if you're bringing in liquid into the data center, how about if it leaks? Of course, yes, that's something to ponder about. How about if it expands? You know, liquid expands when it heated up. You know, what happens? The ease of installations, the ease of being able to service it, after sales support, you know, the constructions from the beginning and all that. Yeah, those are very critical questions. But again, to mention is the fact that Vertiv, in its preparedness, have engineers ready for all that. And in our next slides, we're going to look at how we're going to address things like leak detection and expandability of liquid when it's heated up. Critical components distributing coolants to entire system via secondary fluid networks to cold plates. Intelligence of cooling solutions, controlling flow rates, ensuring steady flow rates and inlet temperatures to IT with embedded monitoring and controls, filtration of extracting impurities out of the secondary fluid networks. Pump and power are key points of redundancy in the secondary fluid networks. Cold plates and manifolds are often single points of failure. Now, for every data center solution, the key word there is redundancy. And so for this cooling solution as well, we'll try to look at a solution where, I mean, a failure on one unit or one component does not affect the entire operation of the data center. So in the design as well, you see that we'll try to make redundancy in the paths of flow into these servers. Okay. So let's talk a little about the flow rates and the inlet temperatures. These are stuff that are regulated right from the design unit and of the application engineer. So the manufacturers of the liquid cooling solutions, the manufacturers of the servers are in sync with standard rates or standard standard units that will be followed through design and production stage that are compatible with both the cooling that comes in the server and then the server itself. Okay, so that's a way to ensure that, yeah, we do not get downtimes and all that, and then the distribution around the servers are in perfect sync with the solution that it should be giving us. So you're going to hit the slides down quickly to the last slide of this feeding temperatures. So these are, we're going to talk about the 5 F's of liquid cooling. Yeah, click down to the last one so that you can talk about them all together at the same time. It's another slide, 3, 4, the 5th one. Go to the 5th one. Oh, great, that is it. Okay, that's it, yeah. So over here, no, you've passed it. Go back, yeah, good, thanks. So over here, we have your, we call them the 5 F's of liquid cooling. Go back. The 5 F's of liquid cooling. So now, over here, we're worried about certain things. What will the feeding temperature look like? Supposing we have a manufacturer from Dell and a manufacturer from HP producing servers with different feeding temperatures. How do we manage this? Are we going to start manufacturing cooling units with different feeding temperatures at all times, every time we have a new solution to make? The answer is no. So your feeding temperature, something like I said, is going to be regulated between the server producing companies so that we have a uniform feeding temperature that works with the servers. An example of this is talking about our phones. If you realize, in the past, or in the early stage of phone productions, we had phones with different types of chargers and charging ports, you know. But at the moment, you see, phones, I think, have a uniform standard of using maybe what we call a Type-C charging port at the moment. So most productions or most companies producing phones come with the Type-C charger so that it is uniform all around, and then we have something to work with across board. So the same thing with your feeding temperatures for servers. Now, the flow rates. Typically, if you on a tap, okay, if you on a tap, there's a speed at which the tap flows depending on the diameter of the pipe in which the water is flowing from. And then another thing to note is if that pipe has what we call a pressure machine, the speed at which the water flows through that pipe is, again, faster, all right? So a uniform standard of flow rate is something we're all looking at so that you don't have to design a cooling unit with a different flow rate from Dell and then a different flow rate for HP. I'm just using these two names against all the other manufacturers we have, you know. I really don't have to mention every other manufacturer, but again, we don't have to have the different flow rate. So this is something we are worried about, and this is something the server company and the cooling companies are working to have a sync and a standard unit of production. Faults, prevention and detection. This is something that is not so difficult to manage. We already know about monitoring units online, offline, from the comfort of your living room and all that. So when we look at the faults and possibility of having preventive measures against what is going to come up, you know, we try to, we already have solutions, monitoring solutions that are able to help us monitor all this. Is my time up? My slide has disappeared. Is my time up?
Not yet.
Yeah.
Is
Time is
my
not
time
up.
is up.
It's not
No,
up.
it's not
Okay.
up. Yeah. I think it's the sharing of the slide.
Yeah,
Oh,
it's
okay,
it's
sorry.
up now.
Okay.
Yeah.
Okay, thanks. So now we have our fluid and filtration, okay? For every liquid, the possibilities of coming with a couple of deaths over time, dust particles, wear and tear of the servers can actually give you some kind of debris in your liquid, okay? So it is a worry for the cooling companies and the server companies and the data center industry, you know? So how do we filter all these debris that's going to remain in the liquid, or the debris that comes in from dust or from other particles over time to ensure that the liquid stays pure and clean? Okay, this is something that the industry is addressing. And then the fluid as well, it is something that is going to be manufactured, maybe of course with different names, but with a uniform configuration or a uniform a color for it, you know. So yeah, so designing and operating of liquid cooling system requires mastering of these 5 F's of liquid cooling. this is what the data center industry is worried about, and this is what they are addressing to ensure that we have a uniform solution. The next slide. Something everybody talks about when we come to liquid cooling is it's leaking. You know, supposing this fluid leaks, yes, this possibility is there. Okay, but the industry is also looking at a lot of leakage detecting systems that can prevent or address a leakage as quickly as possible. So joint development of a product strategy of Intel's growth in the AI space. This is what I'm talking about, a joint development so that the servers manufacturers and the cooling manufacturers have the same compatibility while doing their productions. Two different liquid cooling design options, refrigeration to air cool, and then refrigeration to liquid cooling. All these are stuff that, we've talked about, and we're looking at having a compatibility in our productions. The next slide, we're done with this. So yeah, this is a pictorial view of what we have discussed before. You can see the racks, rack 1, rack 2, rack 3, 4, and RN, on and on and on, you know. Your XAU, which is up to maybe 1,350 kilowatts installed, and then the pipes. You see the red and the blue pipes are the liquid pipes that goes right into your racks and then into the servers, depending on if you're doing your rear cooled or your direct chip cooling. So depending on whichever, this is the kind of solution, and this is how the schematic diagram looks like in cooling your data center space. The next slide. So again, like Okechi mentioned, the next slide, like Okechi mentioned, heat densities will only continue to rise, okay? For our climb in Africa, yes, we are not so much there yet, but we do not have a choice. Before now, a lot of people never use phones. Now we have so much data being consumed with online meetings like these, booking apps, a lot of stuff now carry data, okay? And then it's only going to get better, or should I say worse? I don't know which of the words is preferable now. Yeah, it's only going to get higher, you know, in data consumptions. Sooner or later, hit the next slide for me. We'll discuss this slide already. Sooner or later, we'll be talking about holograms, people appearing to be real on the stage while they're not there. And, you know, all this is the AI stuffs we're talking about, and then they will be generating data. Hit the next slide. We already discussed this. Okay, like the last slide, you know, a couple of these things Okechi already discussed with the team, and that's why I'm hitting all the slides. We already had the data center infrastructure, which he discussed, just like from the ATS, from the power to the ATS, the base solutions, and then down all the power infrastructure goes to the cooling solution. So yeah, from my side, this is a bit about cooling solutions and the Intin, which is liquid cooling, that we will be addressing in the nearest future. So should you have questions and all that, I am available to answer them at the end of the entire discussions. Thank you very much.
Thank you so much, Luther. That was a great session around thermal cooling. And obviously, I'll come to when we have the Q&A. I also have 1 or 2 questions to ask. So we go to the last speaker, who will now share the customer success stories, Olajide Aminu, who will share some live case studies about how these infrastructure principles are currently being applied in live environments. Olajide is the regional account manager.
Sorry, we still have one more presentation. I think Wilson has a presentation.
Okay, Wilson.
Get to my turn. Yes.
Okay, sorry, Wilson. Wilson, please, over to you. So Wilson is, oh, sorry, I missed that. So Wilson will be speaking on power requirements for AI infrastructure. And he's obviously, we know how power is one of the most, if not the most critical issue for AI today. Wilson is, Wilson Ogbaji is Regional Account Manager, Central Africa of Vertiv. He leads strategic power and infrastructure engagement at Vertiv across Central Africa, and with over 15 years experience in power systems and data center design, he supports scalable, resilient platform for cloud and AI workloads. Wilson, sorry if I murdered your name. Over to you.
It's okay. Good morning. Just 2 minutes to noon to everybody. The name is Wilson Ogbaji. Thank you so much. Yes, okay, let's have the slide. The introduction has been done already. Okay, while we wait, basically we're going to be talking about power and power and power and power, without which all that my colleagues have said before now would probably not take off the ground. Okay. Okay. Thank you so much. Okay, so we just talk a bit about our UPS. Not so much to dwell on, but again, introducing our power solutions to back up all what we have been talking about in terms of increase or rise in power densities in our critical facilities or critical environments. And mind you, as my director said at the outset, data center, Vertiv is big on data centers and all of that. But again, we are making inroads in CNI, in healthcare, in education. So these solutions are not just for the data centers that we, as we know them traditionally. We're also looking at making inroads into healthcare, into commercial industrial sector and education sectors. So for our UPS, of course, this is just a schematic showing us how the UPS flows from source, gets into the rectifier, charger, circuits, and the conversion is done, all of that, clean up power, charge the batteries, and send it to the IT loads. Next slide, please. It's just a basic schematic of how UPS operates. Now, in our Vertiv three-phase UPS portfolio, we have all of these lined out equipment or UPSs from our Trinergy Cube to the Libert APM, APM Plus, the EXL, the EXM2, the EXS, and the ITA2. Now, we have our UPSs segmented into two. We have the monolithic UPSs and the modular UPSs. Now, for the modular UPSs, these are UPSs where we have like the Libert Cube, the Libert APM, and the APM APM2. Not showing here now. These are modular UPSs, and they come as the name implies, they come in modules. And these UPSs are, as my colleagues mentioned from the beginning, our solutions are scalable. So with our modular UPSs, it is very easy for you as a data center to scale your power from the day one requirement to the final day requirement. So you don't need to make initial initial cost of ownership is reduced based on what you're looking at day one. You scale up and all of that. Then also we have the other type of UPS, which is the monolithic UPS like the EXL, which has done very well in the market. the EXL UPS. We have them across our region in Nigeria and Ghana, and they have done so well. And the good thing about our UPS is they are lithium battery ready. Virtually all of these UPSs are connectable to lithium batteries and also to the traditional RLA batteries that, as we know them. Next slide, please. Next slide. Now, a little breakdown just to show us the features of the UPSs. These are some other UPSs, MPT type or model, the ITA2, the XS. Now, for, I mentioned the monolithic and the modular, so we can see the APM2, which is a new version of our APM UPS. You can see the performance, which includes the VFI efficiency, dynamic online mode, and parallel configuration. For the APM2, it is up to 96.9%. We can also see from the EXS down to EXM2 and the APM2, they are compatible with lithium batteries and all of that. Please go to the next slide. Now, this is introducing the all-new Vertiv Power UPS 9000. This is a very new product. It's an AI-ready UPS in our stable today. We all know that the way AI loads are structured, AI loads, your data center load requirement can just spike from like, let me just give an assumption. You could just have a spike from maybe like 5 kilowatts to a big jump to like, assuming, let's say like 100 kilowatts. So your regular UPSs may not be able to handle such load. They could just probably dump such loads. But with the built-in capacity of the Power UPS 9000, such spike does not affect the continuous output of this UPS. This UPS is a modular UPS, and it comes in variants of 125 kilowatts modules, and we can have up to 10 of those modules, giving us up to 1,250 kilowatts in one box. As it, you can see the VFI efficiency is about 97.5, very high, and all of that. So let's go to the next slide, please. Okay, now I want to say some more things about power. We're going to be looking at our Vertiv microgrid BSS and bring your own power. Bring your own power. Next slide. Okay, next slide. Okay, now the energy landscape in Nigeria. I'll just take a brief look at what it looks like. Private entities in Nigeria gradually moving towards integrating gas and the BSS. The BSS, of course, is the battery energy solution in our IPPs to stabilize the grid, either locally or nationally. Now, this is, of course, a direction that a lot of private entities are going, trying to bring in their own power to their facility, looking at what the grid is doing currently and all of that, trying to see how they can stabilize their operations. Now there's a Nigerian Energy Transition Plan, which kicked in not quite long ago. There is an amendment to the Act, the 2021 Climate Change Act, and this aims to cut carbon emission in Nigeria by 32% by 2035. This is expected to drive large-scale renewable energy and energy storage investments. If you look around Lagos today, you'll find out that the Lagos state government is putting solar streetlights virtually everywhere. This is in line with this particular act. I'm currently sitting in the federal capital in Abuja right now. In Abuja, you go around, you find solar power streetlights being installed in virtually every place. This is in line with the government trying to cut down on carbon emission, just in line with this particular act by 2035. Energy security, persistent load shedding, and incessant grid collapse now drive diversification through solar and gas to power solutions. Now, this year alone, we have seen the national grid collapse like twice. It's not yet February. And if, as a data center or a critical facility, a healthcare facility and all of that, you depend solely on the national grid, then you'd just be in a mess. I'm sitting down somewhere here. In the last 1 hour, I just had to switch to my phone network to connect to this meeting. In the last 1 hour, the light has been switched off and on over 13 times, which breaks my connection to this particular event or webinar. So that is what could happen to a data center if you solely rely on the Nigerian grid. Digitalization, growing focus on smart grids, advanced metering, storage systems to modernize the power sector. Next slide. We'll talk more as we continue on this. We'll just now an overview of the current trends. Now, the current trends, the AI-driven demand will strain power supply. We already know and probably read what is happening across Europe and America. The guys, they are groaning as concerns power to data centers and other critical facilities. I was in a seminar sometimes back when the CEO of Equinix was saying they're trying to build a data center in France, in Paris, and they're trying to connect to power, but the city would not give them power. So they had to do an exchange. Okay, we'll provide you heat to heat us swimming pools in secondary schools while you give us power and all of that. So it is becoming a huge challenge. And we heard Okechi saying during his own presentation about what is happening in California, where the Silicon Valley is saying the power is not enough for them and all of that. So for us in Africa, as a drive for, or Nigeria, as a drive for AI adoption gain momentum, we expect massive increases in data center load, which will add pressure to the already inadequate and constrained national grid. By 2030, demand for digital infrastructure is expected to, in fact, it's expected to go by 3.7 folds. I just said double here just to be a bit reserved on it, which will require major grid and generation upgrades. So now that we don't even have the power at all, I think this is the right time for private sector-led bodies, data centers, and critical facilities like hospitals to begin to think outside the box on how to bring their own power to their facility. High renewable penetration creates price volatility. Now, growing solar capacity can lead to meet this oversupply, pushing prices towards zero in some markets. Now, if, of course, we know in Lagos, for instance, the time to gather power from the solar grid is just between about 10 a.m. and 3 p.m., which is the critical time we have and all of that. If we don't begin to look at how this power is stored away for use at other times, then we just waste power. And if we're selling that power at that time or putting that power at that time to the grid, it just goes in, it's oversupplied. And at that point, you could even have it so cheap. But when it's actually needed, maybe at nighttime or some other periods when the sun is not so bright, then we don't even have it. Variable generation drives flexibility, and its intermittent renewables require advanced grid management, storage, and demand response to maintain stability. Then data center projects face long connection delays. Now, another problem we see, which are part of the current trends, is that for data centers to secure access to grid. Now, you see most data centers in Nigeria, for instance, would want to connect to the 33 kV line, which for them looks very sure as industrial lines that they can get power consistently from. Nobody really wants to do the 11 kV lines. Now, securing this particular connection takes real time, and they are limited. And government bureaucracies, lengthy permits and all of that will not allow this to happen. And timelines are not met and all of that. Next slide, please. Now, what are the key challenges for businesses? Rising energy costs and availability, escalating electricity tariffs, market volatility make budgeting and planning difficult for these critical facilities like data centers, power reliability issues, frequent load shedding, incessant national grid collapse, like I mentioned earlier, 2 collapse already in January, disrupt operations and increase the risk of, you don't want to bring, for instance, we are moving towards, we have driverless cars in Nigeria, for instance, or you have real-time traffic control at major roads in the country, and all of a sudden there is a cut in power. You already have chaos, or a driverless car, and it could not, it can't connect with the immediate or the closest or data center around. You don't want to imagine what begins to happen in the city. So it is high time we begin to look at all of this, even though they are not with us yet. We expect to begin to see these things in no too distant future. Sustainability pressure. Companies face stricter regulations and growing customer demand for low carbon energy solutions. Now, energy security, grid instability, cyber threats, supply chain constraints, all these threaten energy access, integration of renewable energy, intermittent solar and wind outputs, plus limited storage compilation, complicate adoption. So, as I said earlier, it's not enough to have solar panels everywhere in the country. You have it in the north because this solar harvest level is very high and all of that. Without storage, it negates the reason, the essence for it. Now we have look at grid collaboration in anticipation of the future. Businesses and data centers must begin to engage with DISCOs. When I mean DISCOs, I mean the distribution companies in Nigeria, Nigeria, and government on load management, wheeling, and on-site generation. This is not with us here currently in Nigeria. I'm not sure people wheel their power into the national grid and sell and probably get money back when they're able to stabilize the grid and all of that. But I believe with legislation and going forward, some of these things will begin to happen for us in the country. Please, next slide. I'm trying to rush through because of time. I have quite a few slides to talk through. Okay, no, please go back one bit, one step back. Okay, empowering resilience and sustainable energy solutions. Now go forward. We are going somewhere. Now, what are microgrids? Microgrids are energy systems that can operate in conjunction with a larger grid or independently. And in terms of size, microgrids may be small, powering only a few buildings, or large, powering large companies or entire neighborhoods. Now, for size, there are data centers that are whole campuses. There's a particular campus somewhere in Lekki, which is a data center. Recently, we visited that particular facility and we saw they already installed a gas-fired turbine, about 20 megawatts gas-fired turbine, and they're going to install 2 of that. So in such a place, they're already envisaging the future and getting set for it. Relevance, microgrids provides flexibility, resilience, and greater control over energy supply. Next slide. Now, the key components of the microgrid itself, we have energy sources. We have solar for us, not as much wind here, except maybe for those close to the Atlantic Ocean and all of that. Generators, storage, etc. By storage, you mean the batteries. Thank God for the lithium-ion batteries and newer technologies that are coming up, which enables us to save or store energy even in better forms. Energy loads, data centers, industrial facilities, mines. As my director mentioned at the outset, we're not just looking at data centers alone these days, which is, of course, we are big on data centers. We're also looking at industrial facilities and even mining, which, of course, Vertiv has done some very good, have some very good inroads in Southern Africa region. Connection mechanisms, the means of connecting to and from larger grid. The schematic on the side here, on the right side, just shows the grid itself. Look at the grid, which is maybe a national grid, for instance, and you have your own small grid, your microgrid. Now, there is a link somewhere there between all of that. We have the Vertiv best system. We'll talk about that later. We have the solar, we have the wind, we have the battery charging panels and all of that. We can decide to connect to the grid, and we can decide to be off the grid and just have a local grid just as a point. Now, control systems means managing the grid connection, sources, and overall power flow. Appropriate safety measures has to be put in place, protection and all of that, so that you don't feed wrong frequencies, bad frequencies into the grid and begin to cause problem for other users along the grid. Okay, move to the next slide. Okay, this still, go to the next slide, please. Now, microgrid traditional uses. Microgrids have a wide range of traditional applications to meet various energy needs. Here are some of the applications: high penetration renewables, critical infrastructure, data centers, healthcare, industries, and all of that. Typically, UPS and diesel generators are also part of what we use to generate this power that goes into, the diesel set, for the UPS, just to clean up the power in case we are sending them to the data center or wheeling the power into the data center. Microgrids are crucial for a sustainable and resilient energy future, offering flexibility reliability, and integration of diverse energy sources. So we gather all the energy sources together. In our case here in Nigeria, a lot has to do with gas, but again, I can see a few facilities already moving towards energy storage. There are some facilities along Lagos-Ibadan Expressway, 1 or 2 facilities that have already moved into storing energy in huge battery containers. Move on to the next. Move on to the next. Okay, now, having said all of this, introducing our Vertiv best solution. The good thing about this solution, and virtually all our solutions, they are modular. They are building blocks. So we don't just build one off, and maybe when you want to, when you are growing, we scrap and bring again. No, we're able to build as if we are building on blocks or building brick by brick. Go to the next slide. Now, what does the battery energy storage solution do? The BSS stores electricity for later use, enabling businesses to manage energy consumption more effectively, making it key to resilient microgrids. Next slide. So that is what basically the BSS does. It helps you to keep power. You at peak period when you're using your panels, where you have wind availability, you're able to store power in batteries, and when it is needed much later, you can begin to dissipate that power to power your equipment, your health facility, your data center facility, and all of that. Now, we're looking at some key differences between the best solution and the UPS solution. Mind you, Vertiv has both solutions, but again, the deployments, where they're deployed, how they are deployed, what they are out to serve are very, 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 very different. In terms of runtime, you can see the UPS can help you hold power for between 0 to 1 hour, depending on design. But for the best solution, we can design a best solution for you that can go from between 1 to 8 hours. So for just imagine you buy kilowatts. I don't know how much kilowatt per hour is in Nigeria today, maybe depending, they say 200 and above per kilowatt hour, for instance. And you're able to save. Sir?
I think band A is about 240 or so.
Okay, thereabouts. Okay. Now you're about to a large facility where you use as much as 18. Let's say you need as much as 5 megawatts, for instance, in your facility, and you have been able to save 8 hours of that. You can imagine you're able to gather that through solar and all of that. You can just imagine if you are going to sell back to the grid, you can just imagine the energy, the savings, and the income it gives back. So, power integrated with the grid and renewable energy sources, managing energy flow and storage. So we can do the transfer time for UPS, of course, is instantaneous, ensuring no interruption, 0 milliseconds and all of that. But for the BSS, providing energy within between 1 and 3 cycles, 20 to 50 milliseconds, still very minute, but again, of course, you can never, even in climes where in Europe and other places where you have consistent power supply, they still operate UPSs. This is because the power must be clean, the power must be available without any glitch for critical facilities like servers and some medical equipment during surgeries and all of that. For the UPSs, smaller loads, mission critical facilities such as servers, medical equipment and all of that. But for the best, we're able to put in larger loads in megawatts. So that's a bit different, part of the difference between the two solutions. Then grid services, UPS can act as backup and protect against power surges and sags. But for the best, we are able to use it to stabilize the grid, because the data center, yes, it's about the servers, but the data center itself, in some cases, are big campuses, and you are hooked to the grid. You just don't want issues. So with your best solution, you're able to stabilize the grid, because you have other energy sources or a mix of energy within your facility. Renewable energy integration, peak shaving, load balancing, and all of that. You're able to achieve that with your BESS or BSS solution. Of course, UPS is installed indoors, and requires cooling, but the BSS solution can be done outdoor. We can put our BSS solution, depending on the size, inside a 40-foot, a 20-foot container, and it has its own cooling and all of that inside of it, and it can be placed outside. Scalability, limited design for specific applications with defined power requirements. That's for the UPS. But for the BESS, we have high-level scalability suitable for a wide range of applications, from small systems to large grid-scale installations. So these are just the basic differences between our BESS solution. I think somebody asked this in one of our presentations earlier in the year. What's the difference between the UPS and the BSS? In case that person is on this call, this webinar, I think this should give a clearer view of that. Please, next slide. Okay, now the Vertiv BESS key components. One, the battery storage stores large amount of energy. The power conversion system, converts DC from batteries to AC, which is of course the traditional way it works. The BSS, the BESS control. We have within our own BESS solution, we have the battery management system, we have the energy management system, and the thermal management system. All of these are encompassed within our BESS solution to give us a robust output. Next slide. Now, this particular, I can't see this at the top. As let me just, I don't think anybody can see what's at the top there. A minute, please. Okay, that's the Dynaflex, and it goes from 1.5 to 1 to 1.5 megawatts. Now, this is it's a scalable design also. It has high performance, fast response, about 2 milliseconds response time in terms of conversion, and high efficiency, up to 99% maximum conversion efficiency. So those are just the key points and of this design. It is future-proof, and it is utility-grade storage, or provides robust solution for utility-grade energy storage systems. Please, let's go on. Back to presentation mode, please. Now, the energy core, which is the which ranges from between 4.5 to 5.2 megawatts. This also achieves an efficiency of 99% maximum conversion efficiency. Response time is about 5 milliseconds, a bit slower than the initial one, the one we just mentioned. Reliability ensures over 99% uptime with built-in redundancy. Utility-grade storage provides robust solution. Next slide. Now, what are the key features of the Vertiv BESS? Always on power, provides continuous power supply, grid forming and following, supports both grid connected and island operation. So we can either connect our BESS to the grid or decide to make it an isolated installation. The good thing about it is you can have this BESS and connect a community to it, maybe a community of businesses around to it, and still not have it on the national grid. So you have it standalone. You can equally have it connected to the grid. The microgrid capability is seamless transition between grid and off-grid modes. So you have a connection point where you can decide to put it on the grid, and at any point pull it off the grid and make it a standalone. And as we have always said, our designs are always modular, allowing for good scalability as the business grows. Next slide. What are the applications? Next. Now, of course, we have mentioned in all of the Discord talks, what we've been saying since we have mentioned the applications. You can use your BESS solution in a medical facility. You can use them in education facility, in campuses, campuses where you have laboratories, you have some critical things you're doing within the facility. Your BESS can just come in to help you stay off the grid at some point, and in case you want to connect to the grid to stabilize whatever is coming in, you can also have it there. Next slide. Next slide. Now, the data center plus your BESS is equal to grid interactive data centers. As I mentioned earlier, there are data centers that are as big as campuses, huge campuses. So you don't just need power for your servers, you need power for the entire campus. You have training facilities within the space, you have a whole lot. So you have your data center plus the BESS connected. It gives you a grid interactive data center. Many storage related services are relevant to data centers. Demand charge reduction, distribution deferral, transmission congestion, spinning, a whole lot of that, energy arbitrage. This energy arbitrage for now is not obtainable here in Nigeria. You don't put power on the grid and want to sell and all of that. But I know with the Act of 2021, which has been amended, and I believe more is still being looked into it, because Nigeria's aim is to hit carbon zero, net zero by 2060. It's a tall order, but if we must hit carbon zero by 2060, then a lot of encouragement needs to come. I know already in China they already have such, where small homes can supply the grid from their inverters, from their own small BESS solution in their homes, supply to the grid, and they are paid back for whatever they put into the grid. And so long as they are also able to maintain the grid without putting in bad frequencies and all of that, they get paid for all of that. So we are getting there in Nigeria gradually. Things are moving. I already heard from somebody recently, as recent as last week, that it's like there is a server, there's a liquid cooling enabled server in Nigeria already. There's a server already in the country, maybe not yet activated, but that particular server, if fully activated, would require liquid cooling. So if we have one already, then as we all know, we have what's the name now? What's the Elon Musk vehicle now? The Tesla. We have the cyberspace in Nigeria. Very soon we'll have the driverless Tesla cars in Nigeria and all of that. And all of this, for you to enable them, we begin to think about what we are saying here today. Next slide, we're almost up. Just a little on bring your own power. All that we've been saying since boils down to bring your own power. Increasing prevalence. Bring your own power is becoming more common as higher power loads are delivered to sites. We have data centers in Nigeria today that run on gas fire generators. Strategic integration. Add your bring your own power and BESS to your power sourcing strategy. These are things that data centers should begin to think about. Dynamic ecosystems, microgrids are evolving as dynamic power ecosystems. Decarbonization, focus on environmentally responsible solutions. These are all happening gradually. We're having some data centers already going the way of gas. They are not depending on the national grid as much as they used to. The issue of I must hook onto the 33 kV line is still there, but there are some reservations these days with what the data centers are doing. And I believe the medical facilities, educational institutions would also begin to go that direction. As much as we begin to have the private universities, there are some who already have their own power generation from ground zero. They generate within their facility and they are doing very well. Next slide. So we all know about this, the gas generators. There are several vendors. I just listed two there. These solutions are scalable, short lead times. These engines can be delivered and installed quickly, maximizing downtime. So all of this just has to speak to bring your own power to site, and that is the direction to go. And with the Vertiv BESS solution, you have part of the option being sorted. Our solution is there. All you just need to do is to incorporate your solar to it, incorporate your gas generators to it, and in few cases in West Africa, incorporate your solar, your wind turbines to it, and you have an energy mix, and you are able to meet all of the high demand cost from the grid. The cost of the grid is not just the amount of kilowatts per hour, it's also the cost of not having power. It's not just the cost of the power itself, it's also the cost of not having power, what it means to the data center, what the data center will be losing, what the medical facility will be losing at the time when they need it and there is no power in the grid. Next slide. So in conclusion here, we can see the independent power producer business model. Somebody brings power, IPP, owns and operates the gas turbines located on site. He delivers electricity to this data center, to the campus, to the medical facility, to the school, and gets money back in return and all of that. So you can actually, for the case my colleague mentioned in California, for instance, and the president is telling them, look, you have this money, set up your own IPPs, bring your demands, I'll sign them as quick as possible. I believe today, if you look at Nigeria, I was looking at a report recently, as recent as last week, and they said Nigeria was the 5th producer of electricity in the country. I was like, wow, how? And what was it? I was shocked, 40 gigawatts. We all know the national grid is not above 4,000 megawatts, but they said Nigeria has a production of 40 gigawatts. And I just put one and one together and I said, okay, what it means is a Dangote refinery, for instance, does not depend on the national grid. It generates electricity at the refinery that the fertilizer company also uses. Most of its firms, they fertilize the cement and all of the sugar. They don't depend on government power. The same thing with Indorama, same thing with Tolaram and all of that. They generate their power. And of course, in your own little homes, you generate your power at some point of the day. So put all that together, Nigeria probably is doing 40 gigawatts of electricity. So this is one of those models. We're not going to say much on this, already mentioned. Go next. Go back. So best for us is a new solution in Vertiv. And as of today, this is our footprint, where you have the color blue. This is our footprint of the places where we have successfully implemented BESS. You can see right in Alaska, in North America, part of Spain. You can see in Africa here, around Tanzania, Zambia. These are regions where we have installed base and it's expanding. And I can assure you, before 2030, this blue color would have covered a whole lot footprints across the globe. Next slide. And just to buttress those, just putting them in writing form, places where we have installed: Tanzania and Zambia, in Ohio, US, Florida, Delaware, in Spain, and a whole lot of other places around there. Now, the financial benefits, of course, return on investment. Businesses can see significant savings through energy optimization and energy arbitrage. So this energy arbitrage, I said, for now, it's not obtainable for us here. We're not selling power to the government and getting money back for what we put into the grid. But I know with legislation, with engagement, these things will begin to happen. It's just a matter of time. Incentives and tax benefit, government incentives and tax credits for implementing clean energy solutions. I remember when I was growing up as a little child, I could remember I grew up in the North. There were textile, the North was known as a textile place, and I grew up in a textile community where you had over 8 mega textile facilities in that particular state. They used to get something they call rebates every month, where they don't introduce bad energy to the grid. So when their machines are able to work at unity power factor, these machines don't introduce harmonics and all of that to the grid. The grid is stabilized. NEPA, those days, pay them something. Growing up as a little boy, I used to hear those stories then. So we can still go back to those days where people get benefits. Okay, I'm not going to stay on the grid. I'm going to be on my own, yet I'm generating jobs for the economy. The government looks at me and say, okay, you're doing this. This is your rebate and all of that. We're going to get to all those places. Then energy independence, how businesses can achieve greater control over their energy cost and supply, providing long-term financial security. So these basically are the financial returns for businesses as you implement these solutions. Thank you very much for your time.
Thank you very much, Wilson. And I think obviously the power is one of the most important, like I mentioned. And it's very good that you have walked us through the entire power spectrum and solutions for Vertiv. And now, finally, the last. I hope you can hear me.
Loud and clear.
Okay, so finally, we now have Olajide Aminu, who will walk us through the customer stories. Olajide is Regional Account Manager, Sales of Vertiv, and he's a commercially driven infrastructure professional with experience across technology, energy, and critical infrastructure markets. And at Vertiv, he leads regional account strategy, delivering high-impact solutions across complex multi-market environments. So, Olajide, over to you.
Hi, thank you very much, Timmy. Good afternoon, everyone. Like you rightly said, I'm Jide Aminu, and the task before me today is to walk you through the project reference sites, otherwise called the proof of concept that we have at Vertiv. We've had a lot of presentations today. We've heard from UPS perspective, we've heard from thermal perspective, we've heard from data center perspective, we've heard a lot about the whole of product solutions that we sell. Now the question is, have we done this before, or this is going to be the first time we're deploying this solution? Now you need to see from the global perspective, from the MEA perspective, from Africa perspective, down to Nigeria perspective, what we've done in the past, just to let you know that we are not new in the business. Yeah, so this is at the global scene. In 2012, we deployed a 20 megawatt total capacity data center concurrently within 12 months in Australia. So that means 10 different products, 10 different solution data centers were deployed at the same time, and it took us just 12 months to deploy that. We handled that end to end, from the planning to the processing to the project management, civil works, partnership deployment, and all that. We handled it, and we did it in less than 12 months. In 2013 in Miami, we also deployed 3 data centers by 1.1 megawatts each. We erected the module kit on site. That was in Miami in 2013. In Spain, that same year, we deployed 1,200 square meter prefabricated data center, which was about 1.1 megawatt in total capacity. This one was in 2-story. The first, the upper one had 38 module, and the down part had 38 module as well. And we did that in just 6 months. And the good part about this one is that the certification and design was approved by Uptime Institute. In 2018, we had a turnkey project in Germany, and that was that is standard of EN 50600, and it was a class 4 project. In 2014, we deployed 2 units of 15 megawatts prefabricated data center facility. Again, the designing, the manufacturing, the construction, the civil works, the deployment, and all that, we handled it at Vertiv end to end. In Belarus, 2015, this is at the global scene. So you'll be surprised I'm mentioning a lot of companies that are not in the African region, because we are currently looking at the global region. In 2015, we deployed a 1.1 megawatt data center in Belarus. Again, this was approved by Uptime Institute in terms of the designing and the certification. In the Middle East and Africa, in 2016, we deployed 1,800 meter square data center space, a 2.3 megawatt data center. It was a tier 3 project, and the module were about 200 plus. Dimension data in South Africa, we deployed in 2017. We deployed a 2.4 megawatt scalable colo data center. Now, the scalability allows you to increase your use as the business increases. Now, when the power increases, when the business increases, you have the opportunity of increasing your rack between 120 and 560 racks. So what that does for you is, when the power increases, when the business increases, you do not need to start afresh. You just need to increase the rack within the space provided, and then the business continues. It was a tier 3 project, and it took us 10 months to complete the turnkey project. In 2015, in UAE, we had another IB solution with unique module design. It was also a tier 3 project, and it was a scalable solution. In 2015 in Egypt, we also deployed another 1.1 megawatt capacity data center. This time around again, it was we had the power, we had the battery, the designing, manufacturing, and construction was all done by Vertiv. In between Nigeria and Ghana and MTN, we had a collaboration in 2014 to provide another turnkey project, which was another successful one that was done within 6 months. In Saudi Arabia, 2018, we deployed 3 data centers concurrently across the country, 3 different data centers at the same time. We did that in less than 1 year. It was an 11 megawatt, 1,400 racks, and we did that within 18 months. It was again approved by Uptime Institute in terms of the designing and the facility certification. This project was done in Qatar. This very one you are seeing was done in Qatar. We did it within 19 months, and it has 36 racks, 150 kilowatts per IT capacity rack, and the designing allows for future expansion in terms of increasing the racks. This was the 2.4 megawatt tier 3 data center we had in South Africa. Again, this is also a scalable one. It allows you to scale up in terms of increasing the racks from 120 to about 260 racks within the same space. We had this deployment within 6 months. Unlike the brick and mortar that takes time, that you need to drill some holes, you need to build this, you need to bring something on site. Ours is just that as long as the white space is available, we just deploy the solution on ground and then we kick the ball rolling. This was a work in progress for a site solution here in Nigeria. During this process, we had the crane dropping the containers on site, and like as usual, there is no much work to be done on site. Everything has been done by Vertiv. We just deploy our container and we drop them on site, and then installation takes place. And this is the completed site of the previous slide that I showed you. Down here we have the fire extinguisher in case there is spike. Down here we have the cooling units that allows the cold air to come out and then blow the IT equipment. And at the back here we have the hot air extinguishing the IT space. Just some of the completed projects that we've done in Ghana. Main one, Medallion DLR. We have Ghana GMPC, Cocoa Board Data Center, Ghana Revenue Board, just GRA. We have Ethics, which is now called Onyx, and then we have MTN Ghana. This list, if we decide to update them, we might need to use about 3 to 4 different slides, and we decide to just limit them to names that we might probably know of. And this is another work in progress. Was ready. It was just for us to drop the container on site, and then we had 1 or 2 installations taking place inside the container. This is still a work in progress. It was 3 different containers stacked up on one another. Then at the end of the day, we have everything together. Again, like I said, we do not need much space for our solution. Whatever space you have, we'll deploy something and then we'll customize something that suits whatever white space that you have. So trust me, for Vertiv, space is never a constraint. We have a way of deploying our solution on site that helps you achieve your target. And then this is when the 3 modules have been stacked up. This is the 3rd level. So we have the level 1, level 2, and then the level 3 all stacked up together. So this is the back view of the 3 modules. At the top there is the outdoor unit of the cooling unit that helps you extinguish or exit the heat that's coming out from the IT equipment. This is just to show you that there's an integration between generators and our data center in case you need an extended runtime. I think from Wilson's presentation, he spoke about the BESS, how it differentiates between itself and the UPS, which is an extended runtime. Again, generator is used to increase the runtime that you can achieve on your solution. So this is the codeout containment. In the middle here is the aisle where you can walk through. On the side here is the racks. Those are the exits where the heat comes out, and then in the middle is where you're walking through, and then you have it contained. It is contained because you need the cold air to radiate all through the IT equipment and cool them down. Yeah, this is the section inside the module that is showing your UPS, your power distribution, fire defense systems, and water view. Yeah, this is another power module housing that talks about where the batteries are, the distribution system, UPS, your switch gears, and all of that. This is a smart row solution in Nigeria. Now, the iron you can see on the floor there is the perforated floor where you have the cold air coming out, and then the air coming out will cool the IT space. That allows the IT equipment to cool down. Those are your servers, all the equipment you have racked up within the solution. So this is the fire suppression system inside the power module. Now the essence of having this within the power module is to avoid any form of combustion that may want to occur due to spike within the system. This can occur due to maybe installation, maybe an error from two wires combusting, and what have you. So this fire suppression system helps us suppress whatever fire that might want to encounter, that might want to come up due to the combustion. Yeah, this is a work in progress of a prefabricated data center. Like we said before, the idea is to have the container on ground, and then we have our solution embedded within it. So this picture is just a work in progress picture that tells us that when the work is done, we do not just put the product or all the solutions together. There's a way we align them together that suits our technical designs. And then lastly, we look at the outdoor units of the cooling of the prefabricated data center, neatly arranged, and this is where the heat come out, well arranged in a way that it allows the cooling to blow up the items or the solutions within the container. Thank you very much. Thank you for your time.
All right, thank you so much, Olajide. So we'll get right into the question and answer. One of the things I wanted to ask, and fortunately, Jumoke, Marketing Manager, Central Africa Vertiv, will be coordinating this session. I think we're almost out of time, so we'll have just a few minutes for Q&A. I'll just dive deep into it. Jumoke, are you here?
Yes, I am.
Okay, so my first question, I saw when Okechi was working through the models. Can smart cabinet or any of the smart modes, can it be used for edge? I know those are sort of like self-contained DCs. Can they be used for edge purposes, to improve latency in regions? And then Jumoke, over to you.
All right. So Okechi, would you like to answer that? And then we have two more questions, which each speaker would have, would have 30 seconds to answer, and then we close. So you could go first, Okechi.
Okay. Thank you very much for the question. It's an interesting question for the smart solution. You know, when we call the solution a smart solution, it then means we are trying to tailor a solution to actual customer requirements. Now, one of the things that gave birth to the smart solution was the edge computing. So now we are getting used to computing at the edge. Now, if you want to really bring AI home, it then means you need to have a data center that needs to process the data at the point where the data are generated. So you can't rely on a cloud data center to, for instance, if you have driverless car in Nigeria, you can't rely on the interpretation from a cloud for the driverless car to decide where to move. You're going to be chaos. So edge data center is what you need. So our smart solution will have the one that are designed for outdoor purposes. So I mean data center that can be that's in a rack, that the rack is enclosed, maybe IP35, IP45 range, so it can stay outdoor. It's protected against rain, against dust. So yes, the answer is yes. The Vertiv have a smart cabinet or smart rack that can be used for edge computing. Thank you very much.
Thank you for that, Okechi. The next question, I don't know if Wilson can take this. So it's about digital skills for the AI revolution that is happening when it concerns data center infrastructure solutions. So the person is asking if Vertiv is building digital skills in the local economy that can help enhance, should I say, youths who want to delve into this, should I say, system. So Wilson, please, could you help answer that question?
Okay, thank you very much. When the person is saying digital skills, I'm a bit lost. The kind of digital skills to get, is it in power, digital skills as in AI skills? Maybe Okechi can answer that question because I'm a bit confused now. Okechi, please.
Okay, so can you repeat the question again?
Okay, so the person is asking, so basically the idea is that AI is taking everybody's jobs, right? According to people. But how is Vertiv helping to enhance the digital skills of the youth, especially as an infrastructure solutions organization, to help them, scale up their skills to fit into this new reality?
Okay, thank you very much for that question. When you say that AI is taking a job, a lot of heated debate has really occurred on that. And it's neither here nor there saying AI is taking our job. But what we are saying that AI is the next step. If you do not scale up towards the AI will take over your job. But if you scale and be into the AI system, you will still have your job. Finally, there's never a time machine can control everything. We still need human intervention. So that's why we need to scale all the time. Now, as far regarding the question and as for what Vertiv is doing, now Vertiv have a lot of white papers, a lot of online lectures. I think that's one we have the Vertiv University, where we try to educate people on what is the next and what we are doing and what's in the knowledge you need to acquire. I used to tell someone, for instance, where we are in the university studying, nobody studied, let's say, data center management. Nobody studied AI infrastructure in the university. We all studied engineering, for instance. But now, because we are scaling, we'll meet up, we can get abreast of what is happening. That's why we're able to tune ourselves in and work in line with the revolution that is coming. So now, if anybody have the time and go to the Vertiv website where you see all those webinars, this where YouTube lectures that Vertiv organize, you can get yourself abreast of what is happening and the kind of knowledge and IT skills that you need to acquire for you to be in line with what is going on.
Thank you very much for that answer. The next is to the thermal engineer himself, Mr. Luther.
I'm with you all the way. What's the question?
The question is about liquid cooling and the requirements on how he can have liquid cooling deployed in his data center in Nigeria.
Okay, now that's a very big question to answer because the thing is, we need to first of all have AI-ready infrastructure. Now, what is an AI data center going to power? Have you started doing operations remotely? Like you want to do a surgery, have you started doing one remotely? Do you have driverless cars? Do you have stuff that consume data at that kind of speed? When it comes to liquid cooling racks and servers. So that is one thing we need to look at the infrastructure. But again, if eventually we start preparing for these infrastructures in our data centers, and we bring in a server that can consume that kind of, or dissipates that kind of heat load that needs liquid cooling. Yeah, simple. Just do your calculations on what heat density is needed, and then you recommend a cooling solution that uses liquid for that rack. And like I said from the beginning of the discussion, there are different kinds of solutions when it comes to liquid cooling. So which one we choose depend on what we're trying to power, or what kind of data we're trying to dissipate, and what kind of heat we're trying to expel from our data center. So I hope that answers the question. If not, you can share our emails and then we'll continue that discussion, because cooling is very, very vast and cumbersome. So yeah.
All right. Thank you very much.
Thanks.
Okechi.
Yeah.
Okay, so I just want to add to what Luther have actually said on this. So if you are a user or a data center operator, you want to incorporate liquid cooling in your data center. It's not actually you wanting to incorporate liquid cooling. What normally happens is your requirements, your application, that determines whether you need liquid cooling or not. For instance, if you go to our website, you can see that we have a lot of partnership with NVIDIA, who is the foremost OEM in chip manufacturing, the GPU and co. So now it is the GPU will determine the kind of cooling that will be required to cool it. So the server manufacturers, when they manufacture their servers, they know the kind of cooling that will be required. So from inception, so they will design their server in line with the liquid cooling. Like when the mention was presenting, he said the code plate and how the servers will be attached to a code plate. So now from day one, the server, a code plate has been attached to server. So when you have that server coming, automatically you know you must use a liquid cooling for it. So for you to do this, you using liquid cooling is a function of the application you want to run. And the application you want to run will define the kind of server you will use. The kind of server you will use define the kind of cooling you will use to cool that server. So it works throughout that chain. Thank you.
Thank you very much, Okechi. I would like for us not to go over the time, so I'm going to stop here for now. You can visit our website, www.vertiv.com, for more information. And also we'll be sending an email to everyone who has participated with the emails of all of the speakers today, and then you can directly ask your questions. You could also reach me on olajumoke.rufus, R-U-F-U-S, at vertiv.com. You can send me a mail with your questions. And now I have to hand it over to Tammy. So Tammy.
All right, thank you so much, Jumoke. We'll definitely just add your email to the email that you send out. And we've had a very interesting session today. One of the things we've learned is AI ambition without the required infrastructure on ground, cooling, power, it will create fragility. So enterprises that invest in all this are going to be way better than their competitors long run. So one or two.
I'm sorry, Tammy. Sorry, I just have to. Yeah.
Okay.
Can you hear me?
Yes.
A question just came in now, and the person is asking. Sorry, I have to make an exception. Do you have a customer here in Nigeria? You have deployed end-to-end data center infrastructure, and I find this question very interesting as an OEM, because that's literally what we do. So maybe Okechi can take that for 20 seconds, and then Rita, we would reach out to you to have a further discussion of our end-to-end deployment of data center infrastructure. Okay.
Okay. Thank you very much, Jumoke. You said you find the question interesting. It's actually interesting because the last speaker, Olajide, the slide he took us through was actually on a case studies. The data center will deploy across the world, and more particularly Africa and Nigeria. So we have a lot that we have done end to end. Although I might not, we can start coming to go into detail. We have the likes of Medallion, DLR, which is very close to what's it called, Sakatinibu. Then we have the Medallion. We have the main one, Equinix. So, and a whole lot of other. So maybe if you have your time, you can go through what the Jide shared, so you can see the reference sites. This thing we have done end to end. And currently, maybe I might not need to mention, we have upcoming ones that are happening in Eco Atlantic, a very massive data center that we're going to do end to end again.
Okay, Chi. So now back to Tammy to wrap up.
Okay. Are you done? Can you hear me?
Yes, we can all hear you.
Okay, absolutely. It's been a very great session, and I believe it's been very enlightening to our listeners. And I'm happy to say that everybody waited till the end of the conversation. So our next, like we said, we convene strategic initiatives like this. Our next is our annual Africa Digital Infrastructure Outlook, where we are bringing important, we're trying to have important conversations around the ecosystem. And this so far are some of our guests. And what we really want to do with this is to highlight the importance of digital infrastructure and quickly use that to scale, understand where the scalability is, understand where ambitions need to be translated into execution and reality, and so on. So we invite everyone to join us on that session. Already we have some of these are confirmed speakers, and then we have others who are joining from AFC and so on. So the link is going to be shared in the group right away, and then you can register, participate. So thank you so much. We look forward to seeing you at our next event, February 16. That's also a virtual roundtable. So have a great day, everyone. Thank you so much, Vertiv team, Jumoke, Okechi, Wilson, Olajide, Gary. Bye, everyone.